This is me, Sudarshan, and in my previous video, we talked about force, speed, velocity, and acceleration, and I highly suggest that you go and watch that. So if you just type in awesome science hyphen force, comma speed, it should pop up, and you should see my face, and please do go and watch that if you haven't already. But today we're going to talk about Isaac Newton's second law of motion. 2 videos back, we talked about Isaac Newton's first law of motion, inertia. So you might want to also go back and watch that one too, but we really don't need that today. So Newton's second law of motion is really important, and you might not notice it, but it happens almost all the time, always when something moves. So here, I have a toy car, a Hot Wheels car, and Newton's second law says that if there's no force acting on an object, and then suddenly a force acts upon the object will move in the direction of the force. So, of course, there are 2 forces acting on this car right now, gravity and the force of this table holding it up. But let's pretend there's no force acting on it. So, I'm going to give this car a push, and it moves in the direction of the force. So, and this car has wheels, and this table, so friction doesn't really matter, but if you try to do it on a rug or something, you'll find it won't move as far. You'll need to apply more force to get it move the equal distance on this table here. So, and friction, but let's just pretend there's no force, and I'm going to push it to the side this time. I'm just holding it to the side here. And then it still moves in the direction of the force, but not as far. The reason for that is because the wheels aren't moving this way. They're moving this way, and that really doesn't do any use in this case. So, yeah, it doesn't move as far. But once we get to the gravity issue, if you try to, if there was an inclined plane, or if you're trying to get up a hill, you'll find it being hard because gravity, not really, but it's kind of acting against you. And going downwards is easy also. Going downwards is super easy because gravity is acting with you, and in this case there's not much friction at all. So let me go grab the car. And when you try to go uphill, you need significantly more force. So the reason for this is, like I said, gravity and friction. But I want to talk more about Newton's second law of motion right now. So, first of all, if you know what this means, this capital N means, great. But for those who don't, the physical and proper way to measure weight and any force, which weight is a force, as Newton's. There are a lot of things named after Newton. So, let me draw some object with wheels here. Okay, and then, so a force acting forwards with, let's say, 300 newtons, and a force acting backwards with a force of say 100 newtons. Which way will the object go? The answer is this way, because you can take off the newtons right now, and then 300 is greater than or less than 100. The answer turns out to be greater than, so whichever is greater than the other force, if two forces are acting on it, or two or more, which you don't really need the force of the gravity going downwards like this, and then the force of whatever holding this vehicle up. But it's gonna go this way, like I said, because 300 is greater than 100. And of course, I have a heavy object. So I have a book here, which is a super heavy book. And so it's heavy and hard to push. Of course, I can push it, but it's relatively hard to push compared to this car here. And friction is an issue, but also when you say it's heavy, you're actually meaning that gravity is pushing down on it more because it weighs more, so more newtons, which means more force. But friction is the main cause that's preventing you from preventing me from pushing this book, and preventing you from pushing a boulder up the hill. So I have a question for you. Well, first I do want to say that force, which is represented as F, equals mass times acceleration, or just ma, which equals force equals mass times acceleration, or force times acceleration times mass. And am is a real word, so maybe it's an easier way for you to remember. Force equals something, which it is mass times acceleration, or acceleration times mass, which am. So I have a question, and I'll give you a few minutes time to think, and if you need more time, you can pause the video. But I have an object here, and 300 newtons is acting this way. 300 newtons is acting this way. Which direction will the object go? The answer turns out to be, let me give you a few seconds. The answer is that there is 0 acceleration. So, and I written it as 0a, which means 0 acceleration. It's not like 0 times a, or at least that's not what I meant. So, it could either be moving in a constant speed, or it could be moving it could be staying at rest. So, yeah. And see you in my next video.